Hi there, welcome to the video on Numpy and arrays. Really excited you're here today. We're going to have a lot of fun. And so the goal today is to help you, if you're a beginner, to get a lot more fluid with building and creating arrays. We'll use Numpy and we'll start with one-dimensional arrays and we'll work ourselves up quickly to multi-dimensional arrays. And along the way, I'm going to help provide you some really great tips and tricks that I have personally used to help me grab the concepts, around building arrays and getting a lot more fluid with it. So without further ado, let's dive in and start coding. So I'm in Jupyter and I'm going to go ahead and hit my B key on my keyboard to add in some code cells, and I'm going to import Numpy and use the alias of NP. So let's go ahead and build our first one-dimensional array. A very common function to use is arrange. We'll call then array1, we'll call in numpy, and let's put in our function of arrange. So this calls for values with a start and a stop value, and there's also a step value in here as well. We'll show all that to you in just a minute. Let's just get the array built one dimension and just get one on the table so we can get comfortable and more fluid with this. So we'll just start it with a value of 1 and we'll go up to a value of, let's say, 24. So I'm putting a value of 25 in here because 25 won't be presented. It only goes value from 1 up to 24, but not including 25. Just something to get used to when you're building out these arrays within Numpy and Python. So I'm going to go ahead and print out my array by just typing in print, putting the name of the array inside of it, and then hitting the key to the left. So here we have a number of integers. It is one-dimensional. If you can just imagine, they're just numbers all along the same line. There isn't any depth or dimension to these integers. We can also tell because the number of brackets. There's one bracket on the left, one bracket on the right. It's just one dimension. So the first tip and trick I'm going to kind of get you used to doing as we go through all of these and build these arrays is to print out the attributes of the array. So I'm going to type print below here, pull up array1, and I want to pull up like the number of dimensions. And it's really cool because then as you're building your arrays, you'll always know how many dimensions there are. The next thing I want to do is pull up the shape of it, which will tell us additional information, especially when we get into multi-dimensional arrays. You'll be able to see exactly the shape of what it is that you've just built. We'll pull in the size by typing in array size, which is how many values is in the array. And the last thing we're going to do is we're going to pull in the data type. And I'll show you why that's important in just a minute too. So I'm going to go ahead and print this out. And this says there's one dimension. Again, we'll talk about the shape in just a bit when we get into multi-dimensional arrays. But right now, the size of this is 24. So there's 24 values inside of this array. And it says int 32. So these are integers that have been presented. So why did it just present integers, you might ask? So let's go to our next tip. Help is your best friend and my best friend. We'll go ahead inside of this help function, type in the function of np.arrange and run the code cell, and let's read down here. So I highly encourage you to get used to using help. Your eye will draw to the area that you need to see as you get more and more comfortable with this. My eye immediately draws to this area on the top, which tells me what to input into, or what to input as parameters within inside this function. And it says it has a start, a stop, a step. The data type by default is equal to none. Well, that's interesting. So it presented integers. So I think what we're trying to ask is, why was there integers presented? Well, if you're not getting what you need here, scroll down a little bit and there'll usually be a bit more information, and in this case under the parameters section. And it says the type of the output array for D type or data type, if D type is not given, infer the data type from the other input arguments. And so if you go back, the arguments in this case were 1s and 25s. Those are integers, and so it said, hey, let's present these as integers. Okay, so that's why we have integers presented here. Okay, so I'm going to do just a couple more things before we dive into multi-dimensional arrays. But before I do so, I want you to pause and play around with this. Like start your numbers from 2 and go to 200 for example, or I guess I put 33 there. Go to 200. So here we would expect to see numbers that start from 1 or 2 and go up through 199. And that's a pretty big array. There's a lot of things that are in there. And you can rerun your attribute information down below and see that it says now there's 199 values and this is still an integer. Okay, so play around with that. Feel free to pause whenever you'd like. The next thing I'm going to have you do just real quickly, just to get comfortable moving in and out of these, is let's just change the data type. We know that the data type is called by D type, and I think most of us are probably comfortable with the concept of what a float is. A float is like a decimal. And so let's go ahead and run that, and voila, things change. We now see that these values here now have decimal or dots after them, signifying that this is now a float value. And sure enough, if I print the attributes of this, we'll see that it says that it is now a float. Pretty cool. Okay, so again, the two very helpful tips so far is to print out your attributes for your arrays as you build them and play around with them, and to also use help. To pull in, draw your eye to where things need to be read, and go further down, deeper into the area where it describes the parameters, and just read it and get comfortable with it. And then lastly, I'll just share, because further down below, often you'll see examples of things. Okay, all right, so let's go ahead and minimize this help by double-clicking on the left side in this gray box. And by the way, if you want to see help again, you just mouse over the code cell where that's at and click the gray box again to expand it. All right, so I'm going to minimize this again. Okay, what I want to do is I'm going to reshape this into a two-dimensional array by using a reshape function. And so this will be our first two-dimensional array together. So I do want to do something though that's going to work easily within the context of a two-dimensional array. In this case, this would, because we have values that can be divided by 2. But let me start with something that goes from 1 to, let's go to 99. So we'll put in a value of 100. I want to change this back to an integer. And let me go ahead and run this. So now I have 99 values. And we know 99 is divisible by 3. So we could build a two-dimensional array that's maybe like 33 rows by 3 columns. Let's do it. So the way this is done is we can add a method, and outside of the context of probably this video today, but what I'm doing is basically reshape is a function you can use with a Numpy, but I'm adding it as a method right to this arrange function. And what this is going to do is it's going to allow me to reshape this into whatever size that I would like that would work where things are divisible, correctly, where they can fit into rows and columns. So I know that I can do 33 rows and 3 columns because that multiplied together is equal to 99. So let's run this. And sure enough, it works. So here is something that looks a little bit more like 2 dimensions. We have rows, we have columns, and you can also see the brackets here. There's 2 brackets on the left and there's 2 brackets on the right at the very bottom. 2 dimensions. Pretty cool. And if we scroll down here further below and we print out the attributes, we'll see what changed. This now says it's 2 dimensions. Excuse me. This is a shape of 33 rows by 3 columns. And we still have 99 values within the array itself. Pretty cool stuff. Okay, so let's go ahead and build multi-dimensional arrays using some of the other very common ways of doing so within Numpy. One of those is to use a function called zeros. You will see this a lot, especially if you're moving further in like data science or even statistics. So let's pull up Numpy dot zeros, and as it implies, it's just going to broadcast a whole number of zeros within your array. That's all it does. So we'll call this array2. We'll make it equal to np zeros, and often people get stuck here, right? So what do you do when you get stuck? Let's pull up help. So we'll take our function, type in it a help, run the code cell, and draw our eyes to this area at the top. It says zeros is taking in a shape. So the shape, like a 3x3, 4x4, 2x4x5. So this is where we're going to create our multi-dimensions. And you can read down here further below where it says shape, it says integer or tuple of ints. So a tuple you would input with parentheses. So let's do a tuple of ints, ints being plural. So we'll go ahead and put it in parentheses. We'll do a 3x3. There's two integers, so we can expect this to be a two-dimensional array, a 3x3. Is there anything in here else we need to worry about? Well, let's see. Here's the shape. The data type is going to equal float by default. Okay, well, let's just run this and let's just see what it looks like. I think what we can expect is that we're going to get a two-dimensional array of a 3x3. So we'll go ahead and print out array2, and there it is. All zeros, 3x3. We know it's two dimensions because we got two brackets, and we'll go ahead and pull in our handy dandy attribute coding and just run that real quick. So what I did is I just copied it. I'm pasting it down here and then changing from array1 to array2 because this is called array2. I'm going to run that, and here we go. Two dimensions, that's the first thing we're printing out. This is a 3x3. We can see that. We got 3 rows and 3 columns. The shape of it, sorry, we just went over. The size of it is 9, so we got 9 values of 0 in there, and the data type is a float 64. So very similar. It's like, oh, I don't want floats in there. I'd really like just to have integers. You know, we saw down here in our help area where the data type by default is equal to float, so we can probably change it right from here, and we're going to do that. Data type is equal to, let's say we just want to pass in integers. I'll run that. That looks more like an integer. I'll run that. And now we have integers. Okay, great. Easy peasy, two-dimensional array, just a bunch of zeros. Now, why do you have zeros in there? That is a whole nother video, okay? But just get comfortable building arrays with the different functions that Numpy has, and just get really fluid with it. And then as you go further down the line and learning more about why these things are useful, you'll see the values of what it is that is being used within Numpy. So I would challenge you. How do we create like a three-dimensional array? 3 dimensions. Well, if we go down here, this is taking in a shape. It didn't say that it has to be specific to just 2 dimensions, right? Let's try this. 3 dimensions would be provided with 3 values in the size, or the shape, sorry. So let's go ahead and run this. And we got 3 brackets. That looks pretty good so far. That's 3 dimensions. And then we print it out, and sure enough, we got 3 dimensions now for our array. We've got a 2x3x3, there's 18 values, and we have integers, which is the data type. We could even make this a 4-dimensional array, just by putting in the size of it to be a 4x2x3x3. And sure enough, there's our 4-dimensional array. We print out our attributes, and we have 4 dimensions. So I encourage you to stop, play around with this, get comfortable creating different dimensions. 2, 3, 4 dimensions in here, change the data type from integer to float and back from float to integer, and have a little fun with it. The next thing I'm going to do is we're going to use the same concept, but we're now going to present ones. Ones is another very, very popular use of Numpy to create arrays. And I'm just going to go ahead and, again, click inside this code cell, get my blue color there, hit B, and hit B on my keyboard, and it presents a couple of more code cells for me. So ones is the same way as zeros, so I think we can intuitively know. We'll just build our array equal to np.ones. And we already know that in here we just need to pass in the size, very similar to how zeros work. So we'll pass in, let's just do a 2 by 3. Simple two-dimensional array. And let's say we want to keep the data type equal to integers. So underneath that, we'll print it out. And voila. Ones, we've got a 2 rows by 3 column array, which is in this case 2 dimensions. And again, we can use our friendly attributes to tell us all the things that we probably can already guess about this array. And I basically, again, just changed it to array 3, which is what we have called this array. I'm going to run the code, and we have 2 dimensions. It's a 2 by 3, 2 rows, 3 columns, 2 rows, 3 columns, and we have 6 values in there, and it's an integer. Okay, now let's go take it kind of a step up, and we're going to randomize the numbers inside of our array. This is very, very popular, especially with statistics and other things. And so let's go ahead and, here, let me just kind of clean this up a tiny bit. We're going to use a function called random. So we'll type array 4, and our function we'll call with numpy is .random, and we're going to attach a method to this called randint, and that's going to basically pull in integers. It's going to randomize integers. Now, as always, often people get stuck here. Again, this is developing the intuition of being fluid with things, so just like pull up this into your help menu, open it up, and just, again, draw your eye to things that probably, you know, within the first 1 to 2 sentences. And here it says, oh, randint. Okay, we got some parentheses, so I think we're doing probably pretty good there. So we got to stick some stuff in there. We start with the value low. High is equal to none, size is equal to none, and data type is equal to int. What does that mean? So what I encourage you when you run into things when you're trying them, just like play around with it. Or if you really want to know before you start, you can read further down below. I think we should just go in and start playing around with this. So we know what we have in here, that we have a low value. So we'll start with an integer of 1. The next one is saying is we can input a high value. By default it's none. Well, let's just put like 50. And the next item it says is to put in the size. Okay, well, let's put in a size. Size is equal to, we'll put in a tuple of a 3 by 3. Okay, so intuitively, you know, size, you would probably be thinking that this is, because we're building an array, you need to say, well, what's the size of the array? And that's generally where you input, like, what is the number of rows and number of columns. So let's go ahead and print out our array 4 by typing print, tossing in array 4 and running it. And here we have a 2-dimensional array, which is what we expected by the size. It's a 3 by 3, so 3 rows and 3 columns, so that worked. Now what's all this other stuff? Well, basically it's randomizing values between, you know, 1 and 50. And so if I hit this again, you'll see that these values are going to change. And it does. Oh, there's a 1. And we hit it again and again. So it's randomizing numbers. So really cool to use if you want to develop an array that has random numbers. Now, if for grins you said, oh, I'd like to get exactly what you have on your screen, Tim, well, you can actually do that. It's actually pretty cool. We'll go ahead and seed a value into the randomization, and so that way we all get the same thing. So Numpy has what we call random.seed, and then we'll pass in a value. I'll put 43. That's what we're going to seed it with. So I'll run it again. And now these values will be displayed if your code looks exactly like mine. I'll run it again and again. As you can see, it stays the same. So play around with this. Change your dimensions here. And, whoops. That often happens. So it looks like it changed it to a markdown cell. So I'm going to get rid of that. Go up here and change that back to be a code and run it again. So you can change this to be a 2 by 3 by 3, and then grab your attributes if you want. I just like putting them below, but you can run it wherever you want. But I'll print out the attributes of array number 4. And we will see that it's a 3-dimensional array. In this case, we ran it with 3 dimensions. Here's our shape, a 2 by 3 by 3. Has 18 for the size of it, 18 values inside of the 3-dimensional array, and we have integers. Pretty cool stuff. Alrighty, so I'm going to show you another function which is called linspace, and this is used often as well, because if you need, like, for example, a 1-dimensional array and you need to space values evenly between a range of values, this is going to be a really important one. Let me just go ahead and call it up and put in some values and show you what I mean. So we'll call this array number 5. We're going to go ahead and pull up Numpy, and our function is linspace, and we'll start with, let's say, we want to go from a range of 1 to, let's go a range of 1 to 5, okay? But we want 50 numbers within that range, evenly spaced between 1 and 5. Check this out. So I'll print array 5 out, run it. Now we have values that go from 1 to 5. Pretty cool. And if you count all this, there's 50 values that are in here. And the benefit to that is, again, this evenly spaces things between 1 and 5. So, for grins, if I did 1 to 5 and I just wanted to space it out with just 5 values in there, we would expect to see 1, 2, 3, 4, 5, which we do. But the moment I go to 4, 6 values in there, we're going to have to go lower than just 1. And 2 and 3 and 4 and 5, we go 1 instead of a 2, it's not a 1.8. So now we stuck 6 values in a range of 1 to 5. Anyway, another really good function to play around with and get used to. So I think what I'm going to do is I'm going to close this out by reminding you of a couple of key things. One is when you're coming in here and you're building arrays in Numpy, it's important to be confident in the fluidity of what you're building. Fluidity, meaning that build it and think about what the expected outcome is going to be, and then run it. And if it's different than what you expected, keep playing around with it. And you can use what I have shown you is to print out these attributes of the array, the number of dimensions, the shape, the size, and the data type to really help you get a good grasp of what it is that you're building out. And then the last thing, which is another key tip, is to use the help. It is your best friend. And never be afraid of this thing arguing back with you, okay? I'm going to show you an example of that. So let's say we have values from 1 to 99 and we're trying to reshape it with something that it doesn't quite work. Let's say we try to reshape it into 34 rows and 3 columns. This is not going to work because the shape won't fit into those. And so I'll run this and it's going to argue back with us. always like take some time, scroll down to what it's saying to you, and just read it. This says cannot reshape array of size 99 into shape 34 of 3. So this kind of tells you, hey, you know what, you're trying to shape something and you only have, like size of 99, so it ain't gonna work. You can also take this, copy it into Google, and often you'll get some really great help and feedback back from like different types of websites that are out there. That there's a lot of people who use this, who input their errors, and a lot of people are very friendly out there helping respond back, and generally within the first 5 or 10 things that you get back from a Google search are going to probably be okay. Okay, so I think without that said, one last thing I want to mention is that in an array with a Numpy, things are homogeneous, meaning that we've been playing around with the data types, but you can't make an array with a Numpy be integers and also floats and string values all within the same array. They're homogeneous data types, and so another key thing to keep in mind, and that's very different than what you would be doing with pandas and data frames within pandas, and that's a whole nother discussion. Or lists within Python, because lists can be different types of data or different data types, but you can't do that with a NumPy array. Alrighty, so hopefully this was helpful. I did this because I like helping people out, so have a great day, and thank you so much for listening in. Bye.